Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Rat Run 22 Copyrat by Marty Sears. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Aim of the experiment. Finks and Finks must both reach different cupcakes by finding a path through the maze. The paths must not visit any cell more than once, cross themselves or each other, share cells, or pass through any thick maze wall. Any thick maze walls, I guess. As well as moving orthogonally, which is going horizontally or vertically, Finks and Finks may move diagonally if there is a 2x2 space in which to do so, but may never pass diagonally through a round wall spot on the corner of a cell. So, for example, this is a 2x2 space, so you could have the path going diagonally here, and that would be fine. But you could not have a path going diagonally here, from here to here, because it would go through the round spot on the wall. We have copycat cells, where we need to find 9 copycat cells in the maze, one in each row, one in each row, column, and 3x3 box, and each containing a different digit. So every digit in a copycat cell is unique. The value of a copycat cell equals the digit in the cell that is 180 degrees rotationally opposite it in the grid. For example, if row 1, column 3 is a 6, and row 9, column 7 is a copycat cell, then row 9, column 7 will have a value of 6. So this would have a value of 6 here because that's 180 degree rotationally opposite of it, because it's basically around the center cell, regardless of what digit it contains, right? So if this were whatever digit it is, this has a value of 6 because it's a copycat cell, and must copy the digit that is 180 degree rotationally opposite of it. Okay, we have black courants, where if 2 cells are joined by a black courant, then the value of one is double the value of the other. So for example, if this were, say, a 2 here, this would have to have a value of 1 or 4. We have red courants, where if 2 cells are joined by a red courant, then one has an even value and the other has an odd value. So say this was an even cell, it would say this was like a 2, then this would have to be 1, 3, 5, 7, or 9, because they would have to be odd between them. And finally, we have, well, not finally, we have grapes, where if 2 cells are joined by a grape, then their values have a difference of at least 5. So for example, if this were, say, a 3, this would have to have a say this had a value of 3, then this would have to have a value of 8 or 9. So again, copycat cells could change things, how they work. And the reason is because these have to have a difference of 5, and 8 and 9 are the only digits which have a difference of 5 or more away from 3. And that's an example of how grapes work. We also have a test constraint, and this is the final rule, where in this experiment, in any 3x3 box, the total value of the cells visited by Finks is the same as the total value of the cells visited by Finks. This total must be determined for each box. Okay. So, okay, that's interesting. So that means for every box, the total values of the cells visited by both of these rats must be exactly the same. So say, well, that also tells us that this rat cannot just go straight to here, right? If it went straight here, then the problem is that this would also go here, but then this sum of these digits would not equal the sum for the digits of this rat, right? And it's the value, remember. So that means copycat cells are in play for the paths, right? Because here, whichever, I don't know which one's Finks and which one's Finks. I guess we can choose. I'm going to say this is Finks and this is Finks. Well, Finks doesn't even go to this box, so therefore the sum of these can't be the same if that's the case. So if this goes to here and this goes to here, well, that's not going to work because the sum of this is going to be obviously non-zero, and the sum of Finks's path in this box is 0 because it doesn't ever go there. So keep that in mind as the test constraint. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, interesting thing here. This is a 5 cells which have a 1-to-2 ratio with them. Only one of those. So, the problem, okay. So how does that work? It has to be 1, 2, 4, 8. So only one of them can be copycat because they're all in the same box. And there's only one copycat per box, row, and column. So it has to be 1, 2, 4, 8, and then 8. Or sorry, 1, 2, 4, 8, and then a 4. Or 8, 4, 2, 1, and then another 2. Right? So the values have to be 1, 2, 4, 8, and then 4, or 8, 4, 2, 1, and then 2 to be able to form a set that works correctly. So we know 1, 2, 4, and 8 have to be in these cells. That means the remaining digits in cells have to be 3, 5, 6, 7, 9. And none of these are copycat. So none of these can be copycat. Therefore, this has to be an even digit with an odd digit. So 6 is guaranteed to be here. So this cannot be 6. And we don't know which odd digit it is. So this is guaranteed to have a 6. Also, okay. So as I was saying in the introduction of the puzzle, if we had Finks go here and Finks go here, that doesn't work because then the sum of Finks's path is non-zero in box 3, but the sum of Finks's path is 0. Maybe I should just call them F and P because that differentiates them clearly. F is here, P is here. So F going here would not work. So the thing is, since the paths cannot cross or share cells, what P is going to have to enter box 3. And if I don't know if it's a he or she. I know F is basically a she. But if P enters this box here, they can't get out without getting to the cupcake. So that means P must get to this cupcake here, and F has to get to this cupcake here. So we're going to mark these as, I guess it doesn't really matter, right? This has to go here. This we don't know. This could, okay, so what happens if we do something like this? Then, okay, so the sums of the digits on the pass must be equal in each box. Okay. That means one of these is going to have to go this way. Huh. That's a little problematic. Right? Because you can't... Oh, unless you have a copycat cell. Right. So if either of these try to go this way, I don't think that works. Right? If one goes here, that's already 6 cells, which must equal the same as 1 cell, which is not going to work. So 1 through 6 is never going to add up, or even 1 through 5 plus 1 is never going to add up to 9, a single digit. So this has to, this must go this way, and this must go this way. And one of these two is a copycat cell, which means the rest of the box is not a copycat cell. And since one of these two is a copycat cell, none of these can be copycat cells. Okay. So then these two, one of them is a copycat cell of these. Interesting. And they have to be equal. Because again, this would be at least 7 cells, at least 6 cells to exit out. And it can't be. So this has to go this way, this has to go this way. This must go... Well, we could cross. Both of these could cross. So we don't know which way that goes. So these two must add up to the same sum. This is next to 2 unique digits, which are 5 or more away. So this must be 1, 2, 3, 7, 8, 9. This is next to 2 unique digits, which have a difference of 5. So it's 1, 2, 3, 7, 8, 9. Do we mark cells that you can't enter either? Well, we know you can't enter here, so that's not going to work. But you could enter here, and then the other one enters here. That's possible. So here we have copycat cell here, which maps to these. So we know one of these 5 has to have 2 or 4. These must be the same number because they can't go anywhere else. Excuse me. Okay. Every other box. So every box that it enters the path, you have to have one box for F and two areas for F and 2 areas for P to exit out. Though technically, if you could have 3 pairs, right? So it could do something like F could do something like funky like that, right? Or something funky like that. That's possible because you just count the number of the digits on the path in each box. It doesn't matter. The borders don't change anything. So let's count how many entries and exits each box has. This has that's the reason why this doesn't work, right? This is three entries here, which means you have to have exit out once and exit out once. This has 1, 2, 3, 4, 5. If P goes this way, it could work. It could be 5 digits and then 2 digits here. That could work. I mean, technically, you could even have 6 and 2 works also because you could have the copycat cell. What about 1? 1. So I don't think 1 is entered. You have 1. You have 4. Never mind. You have 4 available. Box 2 has 1, 2, 3, 4, 5. It can't enter here. So 5, which means you can have both of them enter. Box 3 has only 3, so they have to exit both box 3. Box 5 has 1, 2, 3, 4, 5, so they can both enter once. Box 5 has 1, 2, 3, 4, 5, 6, 7. So you could have 1 enter twice and then 1 enter once. Box 6 has 1, 2, 3, 4, 5, 6, 7. So 1 could re-enter twice. 7 has 1, 2, 3, 4. So if it ever enters 7... Okay, so actually that's a good question. Can it ever actually go this way or something? The problem is this would again enter here and then exit back out. So I think the answer to that is no, right? That would be a single digit. This would be at least 1, 2, 4, 8. Right? Because the thing is, this can't be 1, 2, 4, 2. It has to be 1, 2, 4, 8, 4. Or 8, 4, 2, 1, 2. You can't have can't have it in the middle duplicating. Because if you had it in the middle duplicating, the problem is it'd be 1, 2, then 4, 2, then you can't get to 8 anymore, right? Which you have to. So this is so this cupcake cannot go here. Right, so if it enters this way, P has to go this way and then exit out immediately, which is 1 digit. And 1 digit is never going to add up to 1, 2, 4, and 8. Well, could it be 4, 2, 1, 2? It could be 4, 2, 1, 2. Oh. That's not good. Because it could be 4, 2, 1, 2, and 9. Okay. Okay, so if P goes this way, then this has to go this way. But then that doesn't work because P has to also go this way then in that case, which means that P can never go this way. P is either going this way or this way. So what happens if this is 2, 1, 2, 4, 8? So this would then be 8 and 4. That would be value of 2. So that could be copycat. This would definitely be a 1. And this would then be 9 with 6. That could work. So then one of these would have to be 4 and one of these would be 8. Either way, this would have a value that's even. This would then be odd, even, odd, even. Interesting. So then that would be 2 and 8. So even, odd, even, odd, even. Odd. So it's odd. And it cannot be, it could be 1379, 1379. We don't know. This could be 2 or 8. Or 4 or 6. It cannot be 4 or 6 because it's next to 2 or 8 in that case. So this would be even. 2, 4, 6, 8, 1, 3, 5, 7, 9. I mean, that seems feasible. Hmm. Hmm. So if it doesn't go this way, this has to come from this direction. So either here or here. Ah, and how does that work? Well, if F comes from this direction, F can't go through here, obviously, because P's here, then they would share a cell then. If F comes from this way, it has to come from all of this. And that's too far. So cannot come from this way. What about here? Then this would be the same as 1 digit, which is, well, 6 digit is never going to. So this does have to go this way. So we have to go this way. P goes here. That means F can do some funky stuff here. P has to go here. And could enter or exit this way. So none of them could go to, well, I mean, no, you can't really go to box 9. So they both can't enter box 9 because that's going to be really, I don't even know how that works. So then both have to enter box 5. F has to enter box 1. So since F has to enter box 1, so must P. So F has to go, since P has to enter, that means P has to enter, F has to enter then through here, P has to enter through here, and then P must exit almost immediately. So this has to go this way, and then that way. F can do some funky things, but has to go here, then, I mean, could do some funky stuff here, but has to also go that way. P could do something like that, and then F could go around here. That is possible. They must both enter the box 5. So that means F has to go there, and P has to go that way. That means F cannot go here and then here, because then that would block P's path. So F either goes this or just straight. We don't know which. P has to enter here, but it could just go diagonally, right? It could do something like that. Or it could do all 5, technically. Okay. So the value of this, so the value of these two must be the same, because they must add up to the value of this. Since the values must be the same, one of them is a copycat, which means this cannot be copycat here. Therefore, this can't be copycat here. because this is double that one. So this must be 2, 4, 6, or 8. Huh. Because these must equal. Which matches these two digits there. This has to be 4 again. So this is 8. 4. This is 9. That's 6. There's no 9 here, no 9 here. This must be value of 2. This must be 1, and this must be value of 2. And that's the only way that this works. And these sum up to the same sum. So one of these is 2, the other one's 3, 5, 7. That means this cannot be copycat. These cannot be copycat. So one of these two is copycat. No 9 here. This cannot be 1. That's not going to be the sum of 3 digits at minimum. So it can't be 2 or 3, so this must be 7 or 8 here. Okay. 8 eliminates 8 here. So this is 2, 4, or 6. Cannot be 4, so this has to be 2 or 6 here. Interesting. Well, if this is 2, this has to be 1 and 1. So that would be 1, and this would be some other digit. If this is 6, one of these is 3. This must be in a 1 to 2 ratio. 1, 2, 3, 4, 6, 8, and none of them are copycats. 1 can't be here. 6 can't be here, so 3 can't be there. So this is definitely 2 or 6 here. These are definitely even values because of the 4, 8. So one of them's copying one of these. So if this is copycat, that means it has a value of 4, and this would be 4. If this is the copycat, that means it has a value of 8, and then this must be 8. So either way, this is even. So this is odd. This is even. 2, 4, 6, 8. This is odd. This is even. And it must be next to 2 unique digits that are 5 away from it. So it has to be next. This is odd again. So this is 1, 3, 7, 9. This is even. So it could be 1, 2, 3, 7, 8, 9. Or sorry, it doesn't have to be even. It could be. This is 1, 3, 5, 7, 9 as possibilities. We have 7 or 8 here. These digits have to be 2, 3, 5, 6, 7, 8, 9 as possibilities. And this can never be 9, 8, or 7. I don't even think it could be. Can it be a 6? You could have 6 copycat and 1. That is potentially possible. But this digit has to be less than this. Could go around here, and then this one goes. Oh, well, you have copycat, right? So that's potentially possible. So this would be 1 if that were the case. If this is 2. Remaining digits of row 9. Sorry, row 7. We have 1, 2, 3, 5, 6, and 7. Okay. Where is... Well, 9 could be here. Never mind. So value-wise, this has to be 1, 2, or 3. And this must be 1, 2, or 3. Value-wise. Hmm. Um... Hmm. Okay. Can this ever be a single digit? It's possible, right? Hmm. 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 Um. Hmm. Yeah, copycats throw things into a mix. Or things... It throws things into a little bit of a issue. Hmm. Remaining digits of column 3. We have 1 through 5, 7, 8. Okay. Hmm. You're guaranteed that you have to have 2 sums here on P's path. 2 digits here. One could be a copycat cell. Can you ever have... Okay, so one of these has to have a value that's low, and one must have a value that's high. Uh... Hmm. So if this is a 2, you would have to have a value of at least 3 and 5. So then one would be copycat here. Right? Because 3 and 5 already adds up to 8, which is the max this could be, and then plus another 1 would be 9. If this is 2, so that's if that's 2. So then this would have to be copycat going that way. If this is not 2, it's copycat, which means this is value of 2 and 3. Which is problematic. I guess it could be 2 and 5 then, right? It would have to be 2 and 5. So either this is copycat or this is copycat, which eliminates copycat in the rest of the column. Right, so if this is 2, becomes 3 and 5 at minimum. If this is not copycat, it's already greater. This sum is always going to be greater than that, which is not allowed. So it has to be copycat there. It would then have to be 3, 4, and that's 1. And then this would be 8. Right? Because this can't be... if this is 2, this can't be 2. So it can't be 3... in any ways, 3 digits. How do you add up to 8? You have... so 7 has to be 1, 2, 4. 8 has to be... can be 1, 2, 5, 1, 3, 4, 2, 4, 2. I'm trying to think with copycats, right? But the thing, okay, so again, if this is 2, this is at minimum 3 and 5. So it cannot be... oh, one of these has to... this has to be... this can't be 5. Can you ever have a 6 here? 6, 1, and 1. Maybe works. But if this is 6 and 1, 6 can never be next to 1. So this has to be 2 or 3 here. So this is 2 or 3, which makes this... yeah, the thing was I didn't know if this could be copycat, but it can't be because of the way that this works. So if it's 2 or 3, this is 7, 8, or 9. Interesting. This is a low value. So it cannot be 5 here. Again, if this is 2, that's 3. And then this must be copycat because 3 and 5 already add up to 8, which plus 1 at minimum adds up to 9. So that doesn't match. Otherwise, if this is copycat, this could be 2 and 3 as a pair. But the problem is 2 and 3, you could have a copycat here, I guess. You would have to have a copycat there. And it would have to copy 2 to add up to 7, or 3 to add up to 7 or 8. But this would be 2. So, okay, let's go through the scenarios. If this is 2, this is 3, this is 5 at minimum, so that doesn't work. So then this is copycat, and this has to add up to 7 or 8. Well, 7, you have 2 here. This is copycat, so copycat here. Then this could not have a value of 2. To add up to 7 would be 1 and 3, so that would have to be value 3, and then this would be 1. But the problem with that, it would be you would have 1 here, 7 here. This would be value of 3. This would have to have a value of 1 or 2, and this would have to have a value of 1 or 2. So one of them would be 2, the other would be copycat. This can't be copycat, it would be 2. So this would have to be copycat and would have a value of 1 or 2. Okay. This could be whatever digit here. Since this is copycat, this would have to be a 4, 9 as a pair to be 5 away from each other. So no 2, 3, no 9. No 7 here. This is 5, 6, or 8. No 2 here. No 3 here. So one of these two would be a 3. So in that scenario, this would have to be value 1 or 2. That would be, oh, this would be copycat, and then we have a problem. So that does not work to add up to 7. Okay. So what about 8? So if this is 8, then these two add up to 5. You can't go these digits, right? Because that would be at minimum 1, 2. I guess it could be 1, 2, and 2 technically. Huh. I think this is a little problematic, though. This has to be... This has to... If this is 3... This has to be at 3 digits, 5 or greater. So that's 5, 6, 7 at minimum, which is 18. That would be 5, 6, and 7. The problem is then 5 and 7 couldn't be here. So this is value of 3 at most, plus 8 and 4, and that fails. So this cannot be 2 here. So therefore this is copycat here, which means none of the rest of the columns copycat, none of the rest of the rows copycat. This can't be copycat, and it is a 2. So there's no 2 here, which eliminates 2 in the rest of the column. That means this can't be 2. So this can't be 1 here. Right, these had to add up to these at minimum. I guess it could have gone outside. Hold up. No, that's not true. You could have technically gone outside. Okay. So that's not technically true. 2. And then we have green here. So this is blue. This has to be green here. We have blue here. So how does this work? Again, 1, 2, 4. This is 3. That makes this 7 cannot be 1, 3, or 2 and 2. Because the problem is 7 requires a 1 and 2 here, and there's no more copycats. So this has to be 8. If that's the case, that means 8 cannot be here. This cannot be copycat, so it's 1, 2, 3. This cannot be copycat, so this is 1, 2, 3, but no 3 here because of 3 in the box. No 3, 2, or 3 here. This is 5, 6, 7, 8, 9. 8 is definitely one of these, so this can't be 8. No 8 here. Adding up to 8, so 8 minus 3 is 5. So you could have 1, 2, 3, or 4 here. No 2 here. That's fine. So this... So you have 1 here, and that would be 4 in value. So that could work. 2 with 3 in value. 3 with 2 in value here. But it cannot be 2, so this can't be 3. 4 with 1 in value. So that kind of works. This has to be a low, so this cannot be low here. We also have 8 here, so this cannot be 8. Which means this must have a 4 here. So this is the normal value, which means this is the copycat. So this cannot be 4 here. So So this is copycat, which eliminates copycat in the rest of the column. We are not guaranteed that there's a 4 here. This can't be low because we have one low here. These are both low, and this must be low. So this can't be low here. 5, 6, 7, 9. Okay. You could go something funky like that. That is possible. So you could have a... What's the maximum here? You can't have 3, 5, 7 because that would eliminate all possibilities for that cell. So 3, 4, and 7, which is 14. Then you could have 7, 5, and 2 here, or 7, 6, and 1, or 8, 5, and 1. That is possible. And we also have copycat 2 here. So this is potentially possible. Okay. What happens if we have that not 2 in that cell? So say this was not 2 and was the copycat. So then this would be 2. Not copycat here. This would not be copycat here. This would have to be some combination. Oh. Did I think of something else too? I mean, technically, you could do 3, 1, 2, 2 also. We just know 7 can't work there in that case. Can 7 actually ever work here? Whoops. What happened there? So say that's green. No 2. Therefore, this is 2. So say we had... This is not copycat. So it has to be part of these. I guess this could technically be copycat. You could do some funky thing going around here, right? So technically this is not blue either. So this could be the green. Right, so if this is 2, though, this is copycat, so none of these can be copycat. We were guaranteed that this would have to be 1 or 2, even if it goes 4 around here. Right? So that doesn't work either. Yeah, this just has to be 1 or 2. There would be no copycats here. So what happens if this is copycat here? Could this be 7? Well, we have a 2 here. So there would have to be a copycat in one of these two at least. That means this couldn't be 1 or 2. And I don't think that works. Right? So this is... One of these would have to be copycat since this is 2 and this would be 7. Right? We're assuming this is 7. And if that were the case, this has to be 1 and 2 to work. But we already have a 2 in the column, so one of them is a copycat, so this can't be copycat, and it can't be... We have a guaranteed 1 here. Obviously, 2 can't be here. The other's a copycat, so this is 3 at minimum. I guess You could do 1, though, and this would not be copycat. Therefore, this would be copycat this way. This would be 2 and 3. And this would have to be 2, which could work. So you have 2, 3. This is copycat. Wait. Oh, this can't be copycat because of the copycat in the column. So this has to be 2 and 3 at minimum. And then this can't be copycat because one of these requires copycat. So this can never be 7. So that's proving that, I guess. So either way, though, this can't be 7. So this must be 8, which eliminates 8 from the rest of the row. Which means this can never be 8 with this being the copycat. So this is the copycat, and this must be 4. That eliminates 4 here. 8 cannot be any of these. 8 cannot be any of these. So we have 4 here. This is not copycat. Neither are any of these in the column. Okay. So if this is copycat, we know this is 1 through 4. You could technically do something weird like go through diagonal there. That is possible. This is value 1, 2, or 3. If this is 2, then this is copycat. That eliminates 8 from the rest of the box. This is value 2. These are value 1 through 3. This has to be value 1 through 4, but it still could be 1 through 4, right? So that's not too helpful. Oh, if this is 3, 4, 7, then this would have to be 8, 5, and 1. 8, 5, 1, right? That way. To add up to 14. But that could work. Okay. And in fact, oh, because it would have to be 3 there, right? 8, 5, 1, 8. That would have to be 8, 5, 1 then. But that does kind of work. Okay. Hmm. We have low value guaranteed here. Low value here. So this is value 1, 2, 3. This one of these is low value here. This has to be low value also because it's at least 3 digits or three values. And if this is, so this could be up to 4 because this was 3 and this was copycat of 1. That's it. If this were copycat here, then this would have to be 2 and 5 or 2 and 3. So you could technically have 2 and 5 here. And then this is, okay, so then if that's the case, 2 and 5, copycat. This is 1 or 3 then. This could be 1, 3, or 4. 2, 5. So this could be, okay, so well, this can't be 4 anyways here. So 4 has to be either here or here, but 4 could be copycatting something there on the other side. Hmm. Okay, let's go through each possibility then. What happens if we have 2 here? This is blue, 2. This has to be green and copycat. No 2 here. This can't be 2, it's 3, which makes this not 7, so this has to be 8 or 9. This can't be 2 or 3. We have 5, 6, 7, 8, 9. You could go here and then here, which would make that, so this would, okay, so none of these could be copycat. This has to then be, no 4, 5, 7. No 4, 5, 7. No 3 here, so it's 1 or 2. No 5 or 7 there. So this is value. Can you have 1? 1, 5, and 7 doesn't adds up to 13, and 5 and 8 already add up to 13, so no. So this has to be 2 or 3. You could have 2, 5, 7 here, or 3, 4, 7. You cannot have 2 and 3 together with 7. That would add up to 12 at most. So no 1, 2, or 3 here. You guaranteed have a 7 here, so this can't be 7. So it's either 3, 4, 7, which adds up to 14. So therefore you would guarantee have to go around. Or it's 2, 5, 7, adding up to 14. So then this has to be 8, this has to be 5. No 5 or 8 here. So 3, 4, 7. So this is 3 or 5 here. This is 3 or 5. That eliminates 3 and 5 in the rest of the column. Oh, 5 eliminates 5 here. So this cannot, this is 4, 7 as a pair. So that forces this to be 3. This is 5. This can't be 7. 4, 7 eliminates 4 here. So this is 1, 2 as a pair. That means we need a low. This has to be, if it goes to here, it would have to be the low, but it could not be 1 or 2. So it would have to be 4, and that would be 1 and 1. So it cannot go that direction. So it does have to go here. So it would be 1 or 2 here, 1 or 2 here. And this would be value 1, so either that's a copycat or it's a 1. This as a low, this has to be copycat to make that work. So this is 3 or 4 here. And this is copycat adding with that. So this would have to be 5. We'd have to have a 4 here, and it would have to be with 9 since none of these could be copycat. So then this would be 6, 7 pair, which eliminates 6 here, so this would be 9. So that does seem to work. Okay. What about the other path? Because if we can limit this, then the other path would basically be it would be helpful. So this is, say this was the copycat here. That's not 2, so 2 would have to be here. And it's not the copycat. So there's no 2 any of these spots. No 2 here. None of these can be copycat. You have to have, you could have 2, 5, and 1. 2, 3. 1 and then copycat, which would be 2. This can't be 2, so therefore this can't be 1 here. This value again must be 1 through 3. You would have, well, you could have a higher copycat value here. This would definitely, though, have to have value 2 and 3 here, which eliminates 2 and 3 in the rest of the column. So then this would also have to be 5, 6, 7, 8, 9. We'd have 2 and 3 here, guaranteed, as some pair. Or it could be 2 and 5. I guess 3 could be here. Interesting. We definitely have a 2 here, though. You could have 2, 5, and 1. Which would force one of these to be copycat. Or you could have copycat here, right? Which would force this to be a 1, 3 pair. Here, though, you could add up to 15. So this value has to be has to be 3 or less. These values have to be 3 or less. So one of these 3 is definitely copycat. Which means these are never copycat. So this has to be 15 at most. Okay, that's good to know, I guess. So we have that information. So these are never copycat. Right? Either this is copycat, which eliminates copycats from the rest of the column, or this is a 2. This would have to be value 1 through 3 at minimum. This is value 1 through 3, and this is value 1 through 3, and we don't have 3 digits from 1 through 3 here. So one of these is the copycat in that instance. Hmm. Hmm. You cannot have 1 or 2 here, then. I don't even think you can have 3 here. Right? 3, 7, and 3. Well, if you have 3, 7, 3 here, this is 8 at minimum. You can't have 1 and 2 here, because this is value 3. 3 plus 7 plus 1 or 2 is 12 at most, and this is guaranteed to have... Well, you could potentially have 8, 3. 8, 1, 3. But obviously, if this is copycat, then... 12 could work. What we know is 2 can never be here. So this is 3, 5, 6, 7, 8, 9. And one of these is 8, right? If this is 8 and 9, that's 17 already. 4, 5, and 7 can never add up to 17. So this can never be 8. If this is 8 and this is 7, obviously then this is at most 3, 4, 5. Which is 12. So this can never be 8. So 8 is one of these two. You could potentially have 8, 1, 7. Well, if you have 7 here, this can't be 7. But you could have 7, 3, 2. And then 3, 4, 5. Okay, well, if this is 7, 3, then this is 2, 4, 5. Well, this could be value 3 and 4, 5. And then you have 1 and 2 there. I guess the question is, can you ever have this being going this way? I think the answer to that is no, right? What's the minimum? So this is either 2, 3, or 2. Okay, so again, if we have this scenario, this is 3, this is 8. This is not... This is 3, 4, 7 then. 8, 1, and 5 is guaranteed to be that. Even if you do that, it's still similar, right? This is 3 guaranteed. No, yeah, and this would be copycat, right? Didn't I try that? I don't know. I think I did. I'm not sure though. Okay. Jeez. It's making my brain kind of hurt at all the possibilities. Right. So this is always values 1 through 3. This is values 1 through 3 also. Hmm. Did we try that? I don't even know. Did we try going this way? If this was 3. Hmm. What happens if we go this way? What's the minimum? 357, but then this would be 124. So that's not gonna work. What about 367? 367 adds up to, that's not going to work either, right? Anything with 7 here, this becomes at maximum 345, which is 12. So we'd have to have 8 here. And then this is 7. So 457 here, 16. But this problem is 368. And I think that's, yeah, 368 is 17. So the answer is no. And can you have 2 ever? Maybe 7, 1, 1, 3. But then that would be 7. You'd have 3 here too. So if that's 457, it can't be 457. It's 357 at most. 15. 15. This is 8, 3. You could have 1, 3. So we don't have to go here necessarily. Let's just try that then. So this is value 3. This is 5 and 7. And then this is 3 here, 8 here, or 9. It could be 8 or 9. This is this would be, oh, that doesn't work. Huh. Because that would have, okay, so yeah. So that doesn't work. Right, because if we try to have that there as 457, the problem is this do not be 5 or more away from 8. And if we try to have as a copycat, you can't have 2 copycats here and therefore have 1, 1. Well, you could have 1, 2. 1, 2, 3, and 8 add up to 14. 2, 4, and 7. Well, Huh. Okay, let's try again. So then this would be 3 and 8. This would have to be 5, 7 as a pair. So no 5, 7 here. This is blue. And is 2 there. No 2 here. No 3 here. No 5, 7 or 3 or 8. No 3, no 2. So that's 1 or 4. You try to have a 1 and a 2 here. Therefore, this must be a 2. So that could work. So no 2 there. 5, 7. This is 2. No 2, 5, 7 there. One of these is 3. This would be copycat. No copycat. No copycat. So then this would be 2, 5, and 1. So you'd have 1, 5, 4. This would be 3. This would go that way. Therefore, this would be 7. This is so complicated. Anyways, this would be 6 or 9. These would be copycat then. So we don't know what that would be. We'd have 4, 6, 7, 9. No 4 here, so 4 has to be one of these two. I'm trying to have 1, 2 here. I mean, that looks like it works, right? That's pretty complex. So it could do something funky like that. Dang it. The other question I was thinking of is, can it do something funky like that? Right? Does it have to go here always? Can this ever be 7 is the question, right? If this is 7, that would be 2. This value would only be 12 at most. But you could have 7, 3, and then that, which would be 2. So that's possible. Ooh. Okay. There's so many possibilities. You could have P go this way. And then, well, okay, if P goes this way, then F has to go this way around, and that would be fine. If we tried to have P go this way, so there's also this, and then F going here. Huh. So let's look at those possibilities. So P goes this way. F has to go this way here. So that's 2 digits. Obviously, they wouldn't be equal without copycat, but with copycat, they could very well be equal. And it's very convoluted to try to figure that out. What about just going there? Then this cannot go all the way around because that would be at least 4 digits, which are unique, which is 1 through 4. So it could go something like that. So that means either way, it has to go like that. Oh, interesting. So either way, there has to be one path there, but we don't know which path that is. So if we went that way, we had to go this way. So then this would have to go here. And then this would have to go all the way around that way. Interesting. Huh. I don't know. Right now, I'm not really in the mood to try to do this for some reason. Well, I've been doing some other puzzles too, and like getting stuck on trying to go through all these possibilities. And I think my brain is sort of all possibility out right now. So I think I'm gonna take a break here, and then we'll start up on this again tomorrow. Because yeah, my brain I think is all possibility out because I did another puzzle today, which unfortunately I wasn't able to finish, and there was a lot of possibilities there, and I was trying to eliminate all those. And I think this is sort of giving me way too many possibilities also, which is also making my brain sort of like hurt. But at least I can see the path here. The other puzzle I was not seeing the path. So, anyways, I'll see you in the next video then, and see you next time on that video. Take care.